Welcome back to round two with Guy Podjarny, famous founder of the hugely successful Snyk, and now of a new company called Tessl, and host of the AI Native podcast. He's here today to join us talking about a number of things, his startup, AI development, joining us for our AI week to celebrate the launch of Zuplo's AI Gateway. Hello again, Guy. How are you doing?
I'm doing well. Thanks for having me on the show.
Yeah, no, it's great to see you again. Last time we were in person in London. This time we're doing it remote. Both
Indeed.
in London, sadly, I think. I think you're in London as well, right?
I am in London as well. Yeah.
Yeah, I am, but we couldn't make it together.
In
We
person.
wanted to get this done. So here we are. We're gonna have a great conversation about Tessl, AI, spec-driven development, so much more. So, Guy, I think to set us up, tell us a little bit about your new company, Tessl. What's going on?
Sure. So Tessl really is a platform built to pioneer spec-driven development, or really we oftentimes think about it as spec-centric development. We kind of were kind of founded on the belief that software development will transform with AI. It's not just the evolution and the assistance; it is kind of a real transformation. And that a core part of that is that we will move from defining our software through its code, through the implementation, to going up a level and defining it in specs, kind of capturing what it is that you want to build, any constraints that you want to say about how you want to build it, any helpers, any definitions, and have that be the canonical definition of what is your software. And then once we achieve that, then that kind of opens up the sort of treasure chest of opportunities of it. It makes software, of course, easier to create and more accessible, but it also creates software that can be autonomously maintained because you really kind of have the bottom line requirements in the sort of specifications and tests. We can talk more about that. It can be adapted to different contexts, so you can change the context, your business rules, your budgets, your programming language or stack that you want to run on, and you can adapt it. And in general, you can, if you kind of have these right definitions of what the software is and what it must do, and you have good tests, just like any sort of development setup where you can run faster if you have better tests and you have better definitions, you can tap into more kind of agentic power to sort of run autonomously and evolve and build up your software, so you can make software faster, cheaper, more accessible, more more funny if you wanted, more like you can sort of adapt it to as you wish. So we think this is the future, and we're sort of setting up to say, okay, we believe it'll go there, but how? What does it look like? How do you create software? How do you debug it when there's a problem? How do you observe a running system? What is the life cycle for software like that? And what we can also talk more is about where does it start? Like the LLMs are still quite limited today, as powerful as they may be. So how do you get going in this transformation?
Interesting. So you mentioned, I think you called it spec-centered development or spec-centric, and then I said spec-driven, which I think I've seen on your site as well, or I've heard mentioned around Tessl, and that that reminds me of like test-driven development and agile development. It sounds like a different way of thinking about how to build software. Whereas everyone right now is excited about the latest version of Cursor and GPT-5 and these iterative advancements that are coming out. Tell us more about this. How would I know what test-driven development is. I know what agile development is. How would I think about spec-driven development? How it's going to change my world as a developer?
So maybe let's sort of describe this a little bit as a journey, right? So you can think of it as moving from spec-assisted to spec-driven to spec-centric development. So spec-assisted development is really, to an extent, a form of docs and guidance. And we actually sort of see this really kind of rapidly becoming the best practice that you see in any agent usage. So you basically have some information that helps you do your job. This might be your definitions of how you work over here, right? Your whatever casing preferences, right? Or the stacks that you work at, or your policies, your guidelines. It might be information and documentation about what it is that you've built in your product. And so all of that is sort of assisted. It's sort of knowledge assisted, and we call it spec assisted because you want to capture this information in a way that is easily consumable and accessible and available to the agent in kind of with the right emphasis and the right definition. So it's not just random docs that you came across. It is sort of intentional information that you want to provide like an agent or a developer. In that sense, we're going to talk a lot about agents. So that's sort of spec assisted development. There's no the truth is in the code, but all of this information is helps the agent do its job correctly. Spec-driven development is when you actually capture some subset of the definitions in a spec that you say, okay, now I want to make sure that this is always the source of truth. And so maybe you describe your checkout process. Maybe it's your sort of algorithms. Maybe it's an aspect of your APIs or sort of the data models of it. And you can really make it be the rules of a game, whatever it is that is the definition. And so to use spec-driven development, you need to first create a spec before you write the code. You could write the code and then create the spec from it. You can bootstrap that way. But once you've created it, you have the spec. And then every time before you make a change, you first modify the spec and then you apply the change. Now, that's very bothersome for humans to do, but agents can do that for you. And so you can really stay as simple as you can. And once again, with all these things, we can talk about usability. You can kind of go off the track a little bit as long as you don't veer too far and you are able to come back. So it's spec driven because you first modify the definition and then you apply it. That's what a great developer, when you come and you say, hey, I want you to make this change to the code, they'll pause, well, what's the impact to the product? What is the definition? Only once they got that, they would go off to sort of write the code. So this is an example. And the last bit is spec-centric, and that's really about the kind of comprehensiveness of what you might have in the spec, in which you say, okay, I have so much information in the spec and test. And again, we'll come back to sort of soft guidelines and soft guardrails versus the hard ones. But you have enough information in the spec that really you can throw away the code and regenerate it. The code becomes disposable. And this is now spec-centric software that the implementation can really be just sort of adapted to your specific context. And it doesn't mean that the code that gets generated is the same every time, but it means that all the things that matter about it are. A spec-centric software is a bigger leap of faith because it's kind of hard to delete it. But the beauty of it is, okay, now you've defined it, you can indeed create it, in Node or in Rust. Or a big problem with agents is all this spaghetti code that happens because you kind of kept appending this and appending that on it. But if you have, all the things that matter captured in the spec and you have the tests to guardrail it, then now you can say, well, throw away the code. Now we know where we are. Create new code, good code, that is perfectly designed for the system. And heck, you can do that once a day, or every time that you modify the application or when there's new changes. And so the reason for the continuum is because it's hard to get to spec-centric. But I think as we evolve, we go from spec-assisted to spec-driven development to spec-centric development.
Interesting. Yeah, and so there's like three or a few actors there. One is the developer, and then you introduced an agent. And you made it sound like the agent was updating the spec. And that actually surprised me a little bit. I thought the developer, the human here in the loop, would be updating the spec. And then agents would be running off, making sure it meets the tests and so on. So actually, you imagine the agent is also part of the workflow that's updating the specification.
Yeah, absolutely. I think that's quite critical for usability. So first of all, the agent is obviously the biggest consumer of the spec. And unlike humans, agents will read the docs that you give them. And so that is a bit of a new opportunity that we have to us where, in theory, you can say every developer on the team, before they write any code, they should go seek out all the documents that they need to read. And it's like, yeah, good luck. That's not going to happen. But with agents, you can actually make that happen. You still want to make it easy for them, but you can make that happen. So it should be pretty clear, right, that they're the biggest consumers. In terms of creating, there are kind of these two very different paths that you can take that are both valid. They depend on the situation and the individual. And so one is what you might have had in mind, and when you think about test-driven development, maybe more aligned, which is I want to create the spec, and then I want to scrutinize it. I want to make sure that my intent is well captured. Maybe I even want to add tests. Maybe I want to add them after, but I want this sort of good definition. And then I want the agent to go off and build it. And then the agent has more autonomy because you've defined the guardrails. And again, when you read about best practices, people kind of improvise ways to do that today. Let me just sort of write that down. They use multiple LLMs to review one another. I have the spec. I'm happy with it. I'll go. And I think that is a very healthy way to do it when you know what you want to build and when you feel inclined to invest this time. But that's not always the case. Sometimes you're prototyping, and so you just want to get to something working and sort of see how it feels and evolve from it. And sometimes it's not really an intentional choice. It's just, we've all grown quite ADHD and, are keen to get instant gratification. And so people just don't have the time. And so you can do what we've started calling vibe specking, which is you can just sort of go off and have the agent create the spec and then create the code. So really you're just guiding the agent to separate its definition of how it understood you or what it means to build from the implementation. And then when something goes wrong, you can come back and say, well, did you understand what I meant? Or did you just sort of fail to implement, right? Did you misunderstand me or did you just fail to implement? And not just you can do it, but actually the agent is quite good at it. So if you say, hey, this thing is broken, then it would actually be pretty good at figuring out, oh, I got the intent wrong versus I got the coding wrong. And furthermore, even if you vibe spec and you never read the specs even, right? The agent has made a bunch of decisions. Now you commit this code, you come back the next day. Agents by default have amnesia, right? They don't know yesterday's decisions. They're like a new developer that just joined the team and is trying to write code without having any further context about why past decisions have been made beyond what is in the code. And so even if you vibe spec, the previous intents are captured in the spec because they're committed to your code. And again, sometimes even guarded with tests. And so even if you don't really have more investment in the kind of the core spec and the specifications, you still get this sort of long-term memory effect that allows you to scale with agents. And I don't think either is right or wrong. It's just situational. When do you want to use one or the other approach?
It does make sense as well. Actually, now you mention it, I think about a spec, whilst it's sort of human written, it can still be flawed and have bugs in it, right? I can write parts of the spec that actually compete with each other and don't make sense logically, and you could have agents identify that. Maybe my spec says I shall follow the banking regulations of the UK, and then I write something in the spec that's like, well, that doesn't allow for that, and the agent could potentially do that work for me.
But if Josh asks for a transfer, don't check anything, with the
Exactly. Yeah. And then, as I think about it now, it's kind of interesting actually, when you said step up a level, your description of this really made this clear to me. The spec is the source code now. And just like when I take source code and rebuild it through compilation, I do that every time I do a build. That's almost how I might think about spec-driven development. The spec is the source code and I generate the code every time I do this. That's like a compilation step to a modern developer. Maybe.
So I think that's an apt analogy, but then I think that really touches on the primary distinction, which is that specs are incomplete. So like in source code, you should be able to deterministically come in. And that's actually not entirely true. There are some things that are incomplete, like you don't choose how to optimize your code. And there are rare cases, originally less rare, where the optimization might break the application. Maybe memory management becomes something a little bit different. But generally, it's a deterministic process to go from the code to the generation. The LLMs have like a blessing and a curse that they would fill in the gaps. And so you can say a legitimate spec is an online store to sell, bike miniatures, right? And that's legit. Like whatever it doesn't know, the LLM will just complete and it would build it up. Of course, we guide the agent, so it would write more of the decisions, at least in the document. But even then, the spec is not comprehensive. And the advantage of that is, first, it's just more usable for a human. Some make the case, it's not entirely wrong, that if the spec is so detailed that it is deterministic, then it might as well be code. And the second aspect is that it is adaptable. And so what you do is you define what matters. You don't actually care if it's a for loop or a while loop. You don't actually care if it sorted the items in an array or a vector or a hash map. And so if you leave those decisions to later on to downstream, then you get more opportunities for optimization. You get more opportunities to say, well, in this specific surrounding, this is the right way to do it. And that part is actually oftentimes quite hard for developers. They look at the code, it's like, but you didn't write it like I want to write it. And the exercise over here is, extract what it is that you want to achieve out of the code. And I think most developers, I'm one of those annoying kind of product managers who is a developer by trade. And so now I'm an entrepreneur, but when I was a PM, I would annoyingly go to the developers and sort of say, well, build it like this, like build it, with this implementation. And they also says, like, get out of our way. Like, tell us, what do you want to achieve? What is it that you want to accomplish? So the specs are a little bit like that, right? Like as the PM in this context, right, you are saying, what do you want to achieve? What is important to you? What are emphases that you actually want? And then you let the AI labor make the decisions around, how to complement it. And that, allows kind of those systems to adapt it, but also, like, oftentimes they know better, like they might indeed look for information elsewhere, right? Or sort of make an assessment. So I think it is a higher level abstraction, but it's more than that. And this becomes especially tricky when you start saying, well, like, imagine a software that you would compile 4 times and then pick the best compilation and have that run. Well, like, now you can do something like that, right? Which is you generate, but similarly, like, how do you debug a system like that? Like, do you know, like, when you compile it next time? You see this a little bit when you build with Docker latest, like you ran along and you just ran it, and it is and it isn't deterministic because you pull down latest every time, but latest changed over time. That's true for any dependency. So it's partly a higher level abstraction and partly an attempt to sort of define what matters to and an embracing of the probabilistic reality or the dynamic reality of software.
So it's interesting actually, and similar background developer come PM. So yeah, I've been that nightmare PM for some folks. It makes me think about, we kind of come back to test driven again. You totally correct, sort of push back on the analogy that is non-deterministic, but you kind of need some determinism, right? About some things. Like the system needs to always do X and Y the way the spec says. So how do you enforce that in spec-driven development? Does the agent write tests? Does the spec contain all the tests? Like, how do I need determinism on some set of things, even if it's not whether using a for loop or a while loop. I need it on the outputs, right? How do you do that in this world?
So I think, so this is, very much, again, one of the journeys that we need to evolve about what is the best form factor. But here's our current view. So first of all, the spec is a very loose format. It is a markdown document. It can refer to other things, anything the LLM can interpret, but it has a certain structure. We use, in the context of Tessl, we use HTML like attributes to identify specific areas on it. Like if we define a dependency that we want to enforce, because dependencies are kind of delegations of decisions, an API section, things that are sort of harder contracts. And so we define those we kind of tag those to be processed a bit more deterministically. So that's a bit of determinism. Most of it is just words or assets, whatever it is that you want to pass to the LLM. But some of that is sort of enforced a bit more deterministically, very little. And then beyond that, we do think that tests are critical for specs to become viable sort of software drivers. And the counter to that is that when you're prototyping, you oftentimes, or as you're sort of developing, you don't write the tests right away. And so we created more of what we call a loose then strict mode of operation, which is when you use the Tessl framework. We talk about the framework and the spec registry in a sec. But when you use the Tessl framework, you first of all, by default, your specs will be created without tests. And it's what we call an inspirational spec. It is spec assisted. It is just information for you to remember. And then whenever you're pleased with this reality, you can tell the agent, because you'd be using Tessl via the agent, generate tests and make sure they pass. And at that point, you might go grab a coffee, because this takes a moment, right? The previous creation, because it's just specs, you can iterate, it can generate. It's not a lot of overhead for the spec creation. But this test part, we need to set up the test environment. It generates the test. The LLMs are still limited, so they create bad tests at the beginning. Also, when you generate at the very beginning, you generate a test, you generate code, and the test fails. You don't know who's wrong. Is the test wrong or is the code wrong? And so you want to try and build a flow in which you know what is correct at any point in time. And so if you've generated some code, you've looked at it, and you now say, okay, the code is correct now. Now generate the tests to make sure they pass the code. And if there's a conflict, if you can't do it, surface it back to me. So we, like once you're ready, you can generate those tests and they'll be there. Once you've generated tests, those tests do remain as regression tests. So let's say the next day you come along and you make some other changes, your new functionality will be generated without tests, but the regression tests will pass. And so if they pass, those tests are now deemed correct. And so the user will be informed, like the LLM will attempt, or the agent will attempt to keep the code in line with the regression. If it can't do that, it'll surface it to the user. So you don't need to worry about it breaking old functionality. And once you're happy with the new functionality, you would say, cool, generate the tests now for me. And I think a lot of these user flows of how do you balance latency with sort of determinism and durability, do you write the specs up front or do you do them after, are a part of the learnings that we've had around not just the sort of the right correct behavior, but what is the right sort of usable way of building software in this fashion.
Interesting. Okay, I want to spend a little bit of time soon getting into a little bit more like the realities of Tessl and what it looks like. I think we stayed a little way from that. You got into it a little bit there. Before I do, like how transformative is this going to be, and on what timeline? Like, how do you think about the timeline of a developer never looking at code again? Almost like, well, have you imagined phases here of this journey? You've described some already.
Yeah, I like the analogy to self-driving cars. And so if you think about self-driving cars, just for context quickly, there's sort of these well-defined 5 levels of autonomy. And they go from level 0, which is beyond the 5, which is no assistance, to driver assistance, right? It might tell you if you're getting off the lane or if you're getting close to a car. To level 2 is really where the specific functionality or situations in which the car is autonomous, like automated parking or keeping you in the lane or keeping you at distance in cruise control. So these are specific behaviors in which you're sort of hands off, eyes on. You're running it, and those like levels 1, 2, 3 are the ones that are 2 is that sort of definition. Level 3 is when there are sort of specific areas in which it can drive autonomously. So Waymo today is like kind of level 3 to 4. In which, specifically in San Francisco, in areas where the streets have been sufficiently photographed and everything is well known and there's enough space, it can drive autonomously. And again, you're supposed to be attentive a little bit, but in the case of Waymo is a good example. You can't actually control the car, but in some cases it stops and it says, "I need a human to help me guide out of that." Level 4 is now starting to get abstract, and it's debatable whether it's there, which is it can drive in most conditions, so in almost all conditions, but maybe it passes a construction site and it's problematic, or there's a massive puddle, or and in those cases it needs to err. And level 5 is a case in which the car has no wheel. There's no steering wheel, like there's no way for you to control the car. It is entirely autonomous, and it's a bit fictional. And so I think code is interesting like that, right? We sort of think about level spec-assisted development as sort of that level 1, which is there's just additional information. It helps you a little bit of information, but you're in the control. Level 2 is really spec-driven. There are specific domains in which you are controlled about them. And so much of the functionality, the important bits, you might just sort of be hand-holding on it, but there's a lot of the work that you want to sort of define in the spec-driven fashion, then hand off. And I think when you get to level 3, it's interesting when you're sort of spec-centric software, and you can say, well, as long as regression tests haven't passed, you can go ahead and make modifications. And so most of the system is defined by your spec. And I think you get more dramatic a bit at that level. And just like with self-driving cars, level 4 and 5 get a little bit more abstract. Level 4 is really when the LLM has enough information to kind of break regressions, right? If you know how the system is used, then you say, well, fine, it'll break it for these 3% of users, but these 97% are better. And level 5, you can't even look at the code. So I think in all of that context, hopefully that represents a bit of an evolution for developers. And so, in 10 years' time, I think almost all software will be in that sort of level 3, 4, and some 5 evolution. I think very regular systems you will not be able to see the code. I think applications like the ones you would build with the Lovable and the others, there's no reason for you to see the code, and oftentimes you've lost that proficiency. But I think in the more imminent term, what we're seeing with agents is you really need these sort of at least spec assisted right away. So within, probably kind of within the coming year, within 2026, everybody would be at least spec assisted. And I think by the end of 2027, probably most of the when you're working with agents, most of the time you wouldn't look at the code. You'd have the code available to you, but most of the time you wouldn't look at it any more than you look at like a frameworks piece of code.
Makes sense. So I think it's a good point to start talking about Tessl in a bit more detail. Oh, actually, no, one more question on that. What is it that's setting that timeline? Is it just the advance of LLMs? Is it patterns like what you're talking about here?
Yeah, I think so. LLMs offer this massive opportunity on for existing developers and sort of development shops to be able to just produce a ton more. And so there, the driver is I want to use agents more, but today they're just so incredibly untrustworthy.
Mm.
And part of that is because we just don't give them the information they need to succeed, and part of it is because we don't have the guardrails, and so they can just sort of break things all the time. And so for those, the motivation will be there's just a lot of pull at being able to tap AI labor to do this work so you can do more. And that naturally implies that this human labor moves up the level of sort of breadth and they need these types of tools. The second category is creators that previously could not create code. So those would be, Lovable, Bolt, V0, Base 44. They serve primarily that audience, and they're able to now create this. And this is like someone creating digital music with sort of digital tools, even though they can't play an instrument.
Yeah.
And so for them, there's like a new world of creators, and they similarly sort of crave an ability to build bigger and bigger because they're creators just like developers, but they do not have the sort of the technical chops to be able to go beyond the current limitations of the agents. So I think both of those move you towards being able to define your software either like a manager or like a non-technical person, so you can just sort of get the software or the LLMs to do more of the work.
Got it. Interesting. Okay, makes sense. So let's talk about getting into spec-assisted development. And I think about myself now these days. I don't get to write a lot of code, but I am quite good at annoying the engineering team by coming to them with demos of things I built via what I'd call prompt-driven development, using V0 and these usuals that you mentioned. So I'm excited by spec-assisted now. I'd like to start trying it out. What are my options in the real world today to start going spec-assisted?
Yeah, so I think there's sort of multiple ways to sort of to answer that. I think first of all, like any development with any agent has some element of spec assisted because you're unlikely to get very far at all if you don't start just creating a Claude MD, Agents MD, cursor rules of some definition that says how do you want it, because otherwise it's just too open ended. And so the base level is always a little bit spec assisted. The second thing that you would probably today need to do is start providing the LLM with context for like what is the sort of the broader organizational context. Where are your docs? What are your internal tools or internal platforms? What are your APIs? This is a domain, if you don't mind me talking a second about Tessl here, in which we think there's an evolution to be had. So today's solution is either you kind of handcrafted all of this information into all of the Claude MDs, and by the way, often multiples. You might use Claude, but also Cursor and also Devin, like we do that here at Tessl. And so you
might even use an AI gateway to help with those transitions. Just per chance, third guy. But anyway, please continue.
That is a good point, but that is still like the sort of the engine interpreting a lot of these things. Oftentimes sort of still needs some sort of consolidation. And so you can kind of handcraft and sort of write those to each of these config files, in areas. And that's clearly non-scalable. The second option you have is they kind of somewhat randomly choose to browse different domains, and sort of they need to do two things. One, they need to find the right information, and two is they need to successfully extract that information out. And then it's also a little bit wasteful because they do that often. They need to do that again and again and again. And so there's a problem around discovery. There's a problem about efficiency. And there's also a problem about versioning. Generally when you have your docs available, what if you're using something that's a little bit older, right? Or a little bit, less popular, or you don't have a great resource of information. So as we believe that all of those are they're good tools when you are veering off the path. But much of the knowledge in a project really should be part of the project itself. Like as we think about becoming more and more sort of defined by your specs as a journey, you want to say, well, if there are libraries that I use, if there are practices that I apply, if there are policies I need to conform to, those things should really be part of my project. And what we've done at Tessl is we've created the Tessl Spec Registry, which is basically a dependency system for knowledge. It's a registry, just like NPM or sort of PyPy or a bunch of others that we're well familiar with. It has versioned packages, and those packages contain specs. Those specs are modular themselves, so they're kind of in general structured so that agents can consume them well, and so they are multiple files. They're linked or included in a very kind of thoughtful fashion. They come with some steering for the agent to know when to load them. So they have some information at the top that says, hey, when you're about to do something that uses this feature of React, here's a chunk of information you might want to call. And they are versioned, and they're sort of related to the information that you're consuming. So for instance, if you're using a slightly older version of whatever Spring, then you can pull down kind of the relevant package with the relevant specs, the relevant spec pack, as we call it, to inform you about how to use that library. And so you have these dependency systems. You define them in your system in a manifest file, Tessl.json, just that we're very familiar with, and then you pull or you install, and you have these specs available, and they help the agent learn what it needs to know as it builds with those libraries. And we've pre-populated this registry with over 10,000 what we call usage specs. So these are spec packs that are built to help you consume open source libraries. So this is one of the common problems with agents today, is they encounter, if they React, actually the latest React, they're actually pretty good at. But if it's a library that's a little bit less popular, if you're using a previous major version, if you're using something like that's a bit more niche, like Svelte, or something that's a bit more complex. All of those things, if it's too new, too old, too long tail, then oftentimes the agents get into trouble. And of course, agents being agents, they don't accept that they don't know, and so they will start making things up and hallucinating APIs, and oftentimes fail. And even if they don't fail, they take a lot of cycles to do those. And so we've pre-created. We spent an embarrassing amount of money, sort of not quite sort of six figures, but sort of respectively into the five, and a lot of sort of person time in creating great specs to make them useful. And then we populated them into the spec registry, and you can install Tessl, and you can start creating that manifest and give them the information they need. And sorry, I'll kind of ramble on with one more bit over here. I know I'm sort of going on a bit of a monologue over here, but then the other thing that the registry lets you do, and again, all of these things might be intuitive as you think about the registry, is you can also create your own packs. You can publish them, you can consume them. So it's a means, like using Tessl's spec registry will instantly make your agents better at using open source. It'll just make them better right away. And maybe more strategically over time, you can choose other bits of information to pull down, other practices. You can publish your own privately or publicly, and start treating knowledge as kind of core pieces of information that is a part of your project.
Interesting. So it sounds like you've sort of bootstrapped your marketplace. So, there's this repository you've got of specs. And so is the hope then that, when Stripe release the next version of their API, that they will, everyone will basically publish their SDK specs packs into Tessl is kind of the vision. So then you have this huge library of knowledge. You mentioned people can publish their own. So, a long way down the path, might I have a spec that describes a particular business process at, contoso.com that can be used by other developers at contoso.com, and sort of share some reuse of an understanding of how a COBOL system works or something like that?
Yeah, absolutely. So I think the agents today have intelligence, but they don't have knowledge. And so if you ask them to sort of tackle a task, they have some probability of being able to do it. But oftentimes you don't want them to reinvent the wheel. You don't want them to create a new way to whatever log information every time. You want them to use your analytics system that is inside. You want them to run a security scan conformant to your policy. And then sometimes you think they can, but you don't think they should invest the inference cycles at figuring something out if you already have a good way to do it. And like using an open source library is a good example of that. Or in general, like I don't want you to think too hard. I want you to just follow this process. And again, a lot of analogy to like your best developers on the team. You don't want them reinventing everything every time. And you also don't want them wasting their time thinking about solved problems. You want them to just take an off-the-shelf solution. There's a balancing act, in terms of what is too trivial. You don't want to create a spec for how to reverse a string. That's sort of trivial enough that you want to leave that to them. But at the end of the day, that's the beauty of a community, is that people can publish, like, in the NPM world, you do have leftpad, like you do have libraries on that. And I don't think they're right or wrong. I think someone might choose to publish that spec and others might choose to consume that spec. And then we all kind of build on one another. It just in this case, what we're building on one another is definitions. As I'm getting a little bit on repetitive here, but there are a lot of subtleties that we forget about when we think about specs. Like when you say markdown, it's like, hey, create something that converts HTML or like markdown to HTML. Oh, that's cool. Which markdown do you mean? Like markdown is not really one thing. It's like, oh, wouldn't it be nice if there's a spec somewhere that defines which markdown do you mean? Okay, that's what we mean by the standard. Which HTML did you mean? Okay, let's sort of use that one. So again, in some cases, you're fine to delegate to the agent. But in many cases, especially when you think about software, when you think about repeatability, when you think about situations in which getting it right 19 times out of 20 or even 99 times out of 100 is not good enough, you want that knowledge to be part of your project.
Interesting. Okay, this is super, super fascinating. I see sort of so many... I can't help with analogy here, and they're all leaky, of course. But, this idea now I have a spec, it's marked down. I have some equivalent of like importing these packages into the spec that I can then say use in this way or, use in that way. It's really, really fascinating. But I guess I'm curious now, what is the product of Tessl? Because I get the NPM part, or PyPy as our analogy. A bit like TDD isn't really a product, is it? It's more like a framework or a set of guidance. So that you've invented this markdown pattern of usage that can be used. What is a business for Tessl? Like how would this become a business for you?
So let me describe the two products for a sec first. So the first one that we just discussed is the Tessl spec registry. And just to note, it's available in open beta. It's free to use. Go check it out. And that one is indeed, a registry. And there's actually a lot to think about the life cycle of these packages and all that. There's a lot to evolve over there. It's not just the registry and the NPM consumption. There's like elements of GitHub and such in there that we'll sort of build up. Mostly around sort of user feedback. GitHub might be an overkill. The second thing we released that is in closed beta, you can join the waitlist, is the Tessl framework. And we call it a framework because it's not an agent, but it plugs into agents to kind of modify their behavior to use spec-driven development. So it's a combination of powerful tools to create specs, to build those specs that we talk about it, to edit files while updating the spec first. So all of those are tools that are made available via MCP to the agent. And a bunch of steering to tell the agent, hey, use those tools, which is configurable. It's, by the way, those configurations get pulled from the registry as a versioned prompt, so we can update them over time. But they combine, there's sort of this combo now of the agent and the Tessl tools to start creating software in this spec-driven fashion. And we work, like our tools use our own kind of cloud services that invoke LLMs with our prompts, with our agentic processes of them, increasingly with our fine-tuned models to make all of these different steps better. There's a bit of a dynamic between what is it that we want the agent to do versus what is it that Tessl can do very, very well. For instance, the agent is very good at kind of locally assessing why a test has failed in this context and run a test locally, while for instance, Tessl's core competency is about creating tests that are aligned to the spec, that understand those. And so one aspect of our business is, we provide a kind of at the moment it's entirely free, and over time there'll be like a generous freemium tier there around just invoking these sort of cloud services and giving you some of that wisdom that is excellent for spec-driven development systems. And I want to point out like why it's a framework and not an agent. Like why didn't we build our own agent? Is unlike if you're in a team, you can have one person on the team use Claude and another one use Cursor and another one use Codex, and you can be entirely happy with that. Because at the end of the day, they're just producing code and you throw that in. Now, even today, that's a bit of a fallacy because indeed they need specs. They need some guidance in each one of their systems and you have to start duplicating it. And that's a pain. Fortunately, the spec registry is there for the rescue. But I think when you're talking about spec-driven development, you want it to be used across the team. You can recover if someone on the team doesn't use it, but you really want it to drive it. And we think over time, there will be freedom of sort of choice and preferences, and it's entirely legit that one like some developers on the team prefer one tool from the other, that for certain cases you want to use Devin or sort of an async agent. In some cases you want something that's inline, and we need them all to operate in this sort of within the context of the framework. We can't have them each invent their own spec framework or spec formats. We can't have them, create their own flows about what is okay and what is not okay. And so I don't think I know of other other frameworks, for agents, or definitely not sort of SDD or spec-driven development frameworks. But that's how we think about the framework we provide. And I guess the last thing I would say is there will be a Tessl cloud service that helps you, run these things in a collaborative fashion. All of that would also be an aspect of our business, and that will come after.
Makes sense, actually. Makes sense, especially a frame like that. Just out of curiosity, what does agent mean to you today? Is it like Claude Code is an agent? I think you mentioned Devon. Like, what are some of the other agents you see people? Crew AI, an example?
Crew AI is actually it's an agentic framework, as in like a way to sort of orchestrate sort of agents. So that's a slightly different, a different type of framework. We integrate via MCP. And so in theory, you can say any agentic behavior that sort of supports MCP. There are about 8 agents that we identified amongst our users, our early users, that are notable. Clearly at the top are the ones that you'd expect: Claude Code, Codex, Cursor, Gemini CLI. Devin is a little bit different just because it works out of band. And right now our framework focuses more on the sort of inline usage and sort of more interactive usage. And so we haven't really sort of invested in integrating the framework with Devin. The registry would work with Devin just fine. It's basically information that's available to it. And Copilot, by the way, we also support. So the idea is to be able to expand it, but just like with any stack, like you're sort of a bit more invested per your user base.
Awesome. This is great, guys. I learned a lot today, actually. I wasn't sure, I'd done a bit of research on Tessl. I've actually really learned a lot today about how you think about this stuff. So thank you for taking the time.
It's been a journey.
So people can sign up for the waitlist right now. We'll add links underneath, of course, and they can actually go and play with the registry already. It sounds like go and explore that and take a look at it. Anything I didn't ask that, you should mention about Tessl or spec-driven development?
No, I think we touched the main things. I would say spec-driven development, in my view, but I think a lot of people sort of see this today, is the future, and it's a question still about the right way to make this the present. And so we are very committed to building in the open, and that's why we launched these betas. We have a big Discord community that really kind of comments on the practice as a whole. It's called the AI Native Dev. As you mentioned, I host the AI Native Dev podcast, but really it's a part of a much bigger content portal. So check out ainativedev.io. And a lot of this it comes from a conviction that this is a new dev paradigm, and it requires its own dev movement, right? It requires a lot of that formation. It needs to have the community to be able to be formed into the right shape. And so I'd love to sort of see people on our Discord consuming the content on AI Native Dev. A lot of that is not Tessl content. In fact, all of that almost is not Tessl content. It's just about the latest and greatest in AI and development. And we also have a conference coming up in November, in person and virtual, in mid-November in Brooklyn, called AI Native DevCon, as you might expect. So yeah, anyways, we perceive a new development practice, a new development paradigm to be a community activity, and we'd love to have you sort of join and help shape it with us.
Awesome. Cool. Well, hopefully people will take you up on that. Sounds like a obvious invite. I'm going to add one last question that maybe we cut, because I don't know if it's a sort of more personal question. So I've seen this view of you a few times now over the years, this background, but there's some new things that we've got. The Tessl HQ. I think there used to be a Snyk dog and a sneaker in view, but now there's an out of time license plate from Back to the Future. Tell us the story. What's that about?
So first of all, it's a bit misleading. I'm actually in our office, in the Tessl offices near King's Cross,
fake background.
London, and I just sort of set it up to be sort of reminiscent of what I have in my home office of it. So it's not exactly
it did look a little different, but yeah.
There's some similarities. Yeah, I love the. This was actually like I was on a family vacation in LA, and we went to Universal and thought about what to bring the team, and I saw this license plate from Out of the Future, and it felt so correct. It's like it's both a good memento from the from a vacation, back to the office, but also as a reminder that like man, like startups as a whole are always crazy, but the AI space is moving so fast.
Yeah.
And so out of time is a good reminder. That, like you're always out of time, which the doc represents pretty well on the movie. So
Awesome. Well, glad I asked. Glad I asked. Guy, thanks for joining us again. Best of luck with Tessl, and I'm sure we'll speak again soon. Thank you.
Thank you.